Good day everyone, I am Vincent G. Bilacho and today I'm going to discuss the geophysical investigation. I'm going to talk about first the geophysics. Geophysics is the study of physical properties and behaviors of the Earth. It makes use of the data available in geodesy, seismology, meteorology, and oceanography. Geophysics includes all from understanding the microscopic properties of minerals and rocks to global processes like earthquakes and climate change, exploration of coal, oil, gas, and geothermal energy resources as well as groundwater and mineral deposits, assessment of earthquake hazards such as strong ground shaking and landslides, investigation of subsurface for engineering structure, imaging of the subsurface for environmental hazards are some of the areas geophysical engineering deals with. It is important for us to study geophysics because mapping large geological areas in order to improve our understanding of the Earth's structure and finding and recovering resources like hydrocarbons, minerals, and groundwater. Next is seismology. Seismology involves sending acoustic energy which takes the form of wavelengths into the ground to get a sound picture beneath the surface. Seismology is important for studying the Earth's interior because it has a higher solving power than other geophysical methods. So the technology which measures reflected acoustic energy waves is primarily used in coal, oil, gas, and geothermal exploration. Geophysicists and geologists can map the subsurface structure of rock formation using seismic imaging. Sound waves can be reflected or refracted due to differences in the properties of different rocks. Seismic imaging is accomplished by passing acoustic energy waves generated by a sound source through these layers. This information tells geologists where rock properties change and aid in the discovery of oil and gas deposits. There are typically two methods for producing the source sound waves. The first is to use vibroseis, and the second is to use explosive detonations. Vibroseis is also known as a tamper or a shaker unit. It is a large hydraulic ram installed on a special truck. It rams the ground with a tamper resulting in a series of source waves. Geophones, which are specially placed microphones in an array around the survey area, pick up the reflected sound waves and record the data to digital medium for later computer analysis. Occasionally, instead of using vibroseis, explorers will use an explosive such as dynamite to generate the sound source waves. Explosives are placed in shallow drill holes beneath the earth. An acoustic shock wave travels through the ground when the explosives are denoted. Next is gravity. Mountains, ocean trenches, tidal movements, and even large buildings and structures can affect the Earth's local gravity field. This, as well as the composition of elements within the Earth's crust, all cause micro variations in gravity all over the Earth. Gravity surveying measures the change of rock density by looking at changes in gravity. This technology is used mostly in minerals, coal, oil, and gas industry. Gravity surveying provides geologists and exploration managers with a picture of the subsurface geology of a surveyed area so they can see what's in underground. Geophysics routinely measures this microvariation using either ground-based or aerial instrument readings taken by gravitometer. Gravitometer works by recording the downward acceleration of mass from the minute fluctuation of a finely balanced spring within the gravitometer. This device is known as accelerometer. The accelerometer used in gravitometers are extremely sensitive to small fluctuation in gravity. For ground-based gravity imaging, A portable gravitometer, the size of knee-high box, is placed on the ground at sequential points along predetermined grid. The operator records a reading at each successive points and advances to the next point along the grid, a utility vehicle. Once there are enough readings recorded from the grid, the data processed by a special computer to create a detailed map of the surveyed region. So next is electromagnetics. So electromagnetics is based on the response of the ground to the propagation of electromagnetic fields. Electromagnetic methods, both airborne and ground, are one of the most widely used geophysical techniques in mineral exploration, in which natural or controlled sources are used to transmit electromagnetic waves into the earth and measure the returned electromagnetic fields. The electromagnetic methods include the radio imaging method, ground penetrating radar, borehole radar method. They are used not only for the discovery of mineral deposits and extension of reserves of existing mines, but also for structural mapping of the earth, oil and gas exploration, environment and engineering, and groundwater investigation. The ability of these methods to explore deep earth has improved significantly in recent decades with advances in sensors, space and drone-based observation, electronics, data processing, and inversion techniques. All these have improved the resolution and detectability of electromagnetic methods. Ground penetrating radar, a method that uses pulses to image the subsurface. It uses electromagnetic radiation. Ground penetrating radar is a geophysical locating method that uses radio waves to capture images below the surface of the ground in a minimally invasive way. The huge advantage is that it allows crews to pinpoint the location of the underground utilities without disturbing the ground. Ground penetrating radar requires two main pieces of equipment, a transmitter and a receiving antenna. The transmitter sends electromagnetic energy into the soil and other material. Ground penetrating radar works by emitting a pulse into the ground and recording the echoes that result from subsurface objects. Ground penetrating radar devices also detect variation in the composition of the ground material. If the electromagnetic impulse hits an object, the density of the object refracts and scatters the signal. The receiver detects the returning signals and records variation within them. The system has software that translates these signals into images of the objects in the subsurface. This is how it is used to map structures and utilities buried in the ground or in man-made structures. So that's all for my report. The next slide will be discussed by Mr. Norijan Ambit.